Hi everyone, and welcome to the new episode of our Brown Bag Meetups. And I'm your host Alip Talipov, and today we've got our guest Erhan Saygi, who will be presenting about the VMware blockchain platform. And this event is hosted by the blockchain professionals community. And if you are new here, we are kind of a think space of blockchain enthusiasts, blockchain engineers who are interested in blockchain as a concept, as a technology, and who are also aimed to accelerate its early adoption. And before we start, I just wanted to let you know that we also have got many other interesting activities in our community, such as conferences, podcasts, and articles. And the next big event is the Blockchain Professionals Hackathon coming this June. If you want to learn more, please visit our website and make sure to subscribe to our social media channels. And I will now invite Erhan to the stage. And if you will have any questions, just type them into the live chat on YouTube and we will read them aloud by the end of our today's session. Hi, Erhan, how are you?
Thanks, Alikan. Can you hear me?
Yes, it works. Just let me bring your screen to the stage. Yeah,
Oops.
could you please
Yeah.
open
Let
the
let.
presentation?
Yep. Okay. I assume you can screen my screen. You can see my
Yeah,
screen
so
as well.
perfect. Okay, I think it works and the stage is yours, Erhan. Good luck.
Thank you. Thank you. So maybe I'll start by introducing myself. I'm based in Singapore. I'm a blockchain specialist, field engineer covering the APJ region with VMware. And I have been with VMware blockchain almost 2 years now, based in Singapore, as I mentioned. So what I will cover today is, I'll start with the introduction to VMware blockchain, how the product came to the in fruit as well. Then tech innovation parts, the technical details of the platform. I'll talk about how you deploy and how you manage some of the data operations, and also do a demo of deploying smart contracts into the platform itself. And obviously, we will have a Q&A session at the end. So I'll leave like 20, around 20 minutes at the end. So I think if you have any questions, we can cover at the end as well. So let me start with the history of VMware blockchain. It started as a research project back in 2016-17 in VMware research. Output of that was a consensus algorithm, and it was open source as Project Concord. We also wrote a white paper covering that, and eventually the VMware decided to build a business unit around it, and the first version of the product was released at the end of the 2020 as focusing mainly on the financial services industry, using the DAML smart contracts. And this platform is now on production with the customers. So you can think it as a platform like the other blockchain platforms. You can deploy, and you can, after you deploy the blockchain network, you can deploy many use cases or smart contracts as you want to. I'm not going to spend too much time here. Probably you guys know why do we need a blockchain or a system for the multi-party applications? As you know, with the traditional systems, there are many point-to-point connection. Each of them might have different data protocols or storage systems. The way to store data might be different. So what eventually this leads up to a slow, error prone and difficult to audit the environment, right? Because each of them is being a different. Obviously, with a blockchain or VMware blockchain system, you are operating out of a single shared source of the truth. All the participants are in the network, assuming they're entitled to this information. They'll get a real-time notification when something happens, so that they can trigger their back office operations or other operations. So because of that, it reduces business risk, increases the liquidity in the network, etc., etc. So the traditional blockchain benefits in this case. So if you look at like the unique properties of VMware blockchain, on the left-hand side, I will say more blockchain capabilities. And on the right is more non-functional kind of like things that we bring on the table. Um, Obviously, the integrity. We implement a Byzantine fault-tolerant consensus algorithm. So up to 1/3 of the network can be down, and that down might be software or hardware errors, or it can be even malicious actors. So the BFT protocol provides guarantees that up to 1/3 of the network can be done, but it will still provide the liveness and safety guarantees to the network. Um, Privacy, obviously, if we, especially with the DAML integration, we provide the privacy at the sub-transaction level, meaning that a transaction might have multiple sub-transactions and the actors involved or the parties involved on those sub-transactions might be different. But even at that level, we can commit the transaction atomically, but we can still provide the privacy at the sub-transaction level to the relevant parties. Authentication and verifiability, obviously, this is kind of like a blockchain system that the messages get signed and verified at each every step and each every layer of the blockchain. And the data can be verified independently in this case because of the Merkle proofs, etc. And in terms of the performance, we can support up to thousands of transactions, real life transactions on the platform. I mean, some of the our customers are running very heavy transactions and kind of like we can scale to meet those kind of demands. Deployment and upgrades. So we provide tooling to deploy, very easy to use tooling to deploy the platform. So basically, by providing a couple of input files, you can deploy a fully functioning production-grade blockchain network within minutes to your target infrastructure. It could be on premises using vSphere, or it can be AWS natively or Azure coming soon. Um, so we provide multiple endpoints, infrastructure endpoints, but we use a similar tooling to do the deployments. Same with the upgrades. We provide upgrades with data continuity, and this tooling also lets you to do other operational activities like key rotation or stopping the blockchain if you want to take a kind of like a reliable backup, etc. So we have tooling to provide those kind of functionalities. Monitoring and logging, obviously, this being a blockchain system, there are different layers, and it generates lots of logs and monitoring matrices. So those matrices at each layer of the stack are sent to the monitoring endpoint that you prefer. We provide pull or push matrices, so you can in the Prometheus format, so you can pull those matrices from the platform itself, or we can send it to like Wavefront, for example, which is a VMware product. Same with the logging. I mean, it can be sent to any HTTP endpoint, logging endpoint, and with some native integration with Log Insight, Log Intelligence, or if you are using AWS's CloudWatch, etc. With the support, we have two levels of support. Obviously, we have the VMware global support. We also SREs, SMEs, fully dedicated for the blockchain. They are around the world and they cover customer queries regarding the blockchain systems. So in terms of the architecture, we have a very modular architecture. So if you look at this picture on the bottom layer, we have this state machine replication protocol at the VMBC core layer. So basically the consensus layer and on top of that, this key value ledger, which is the data storage for the blockchain, is common across all the options above. And in terms of the smart contracts support, we support DAML smart contracts, and as well as we have EVM support, which is in tech preview stage now. So the customers can choose their choice of smart contract language, called DAML or Solidity, and deploy into the platform. Um, and but I think the important thing is that the bottom layer or the day two operations in this case are the same. So the customer get the same kind of like the benefits or the use from the platform itself. And in the future, we might support other smart contract languages because the platform allows that. Uh, but at the moment, we have DAML in production, and EVM is or Solidity is kind of like a tech preview state with in the platform. Um, in terms of a basic deployment architecture, this is how it looks like. This is kind of like an example from the DAML deployment. So we have two types of nodes. On the right, we have the replica nodes. Collectively, they form the Byzantine fault-tolerant replica network. So in this example, we have 4 of those replica nodes. And as I mentioned, we can afford to lose up to 1/3 of them. So in this case, one of the replicas can be down, but the network will be able to process transactions in this case. And in the middle, we have the client nodes. Those are basically the interface between the parties, outside applications, and the blockchain network or the replica network. So the parties can send transaction to client nodes, then client nodes will forward this request to replica network. A replica network first will reach a consensus on the order of execution among those 4 replicas. And then each of them independently will execute the transaction, and they will record the output into their storage. And they will return 2f+1 responses back to the client node. So in this case, you expect to receive 3 responses, 3 equal same responses from the replica network. So at that point of time, the client node knows that the transaction is successfully committed, and it can update the parties saying that the transaction is successful and this is the output. The client nodes also keep a privacy filtered subset of state in their local storage. So if there's a read request coming to client node, they can respond using this state database that they have. And as I mentioned, that's privacy filtered, which means if there's in this example, if there's a transaction between party C and party D, the client node that party A and B interacts with, we will not get a copy of that transaction. So that's kind of like the privacy filtering capabilities as well. That party to client node mapping is stored at the replica node, replica network. So the replica network knows for each data update or addition onto to the ledger, it knows where to send this information back to. In this case, it will not send to the client node on the top. As I mentioned, we have 4 replica nodes. We can afford to lose one of them, and this client nodes can be deployed into pairs. When you deploy in the pairs, they become kind of like active with some consideration or obvious application consideration. But if one of them fails, you can fail over to the second one if you want to. So that those are the high availability kind of like a functionality. And in terms of the deployment, those are all the nodes here are virtual machines. So the package has virtual machines. And there are a bunch of Docker containers running inside. So we have a tooling, which I mentioned before, orchestrator tool appliance. So it can deploy the blockchain network, create initial configuration. And once the network is deployed, it will start the bootstrap process. And after that, it will do a key rotation among the replicas. And after that, the replica and the blockchain network will be operational. So it's basically, in this example, we will have 6 virtual machines, 2 for client and 4 for replica networks. And they will be running different kind of like the Docker containers based on the type of the node. We have other nodes, but I think type of nodes, but I think for kind of like a simple architecture, this is what we deployed. We deploy. As I mentioned, this is the DAML deployment. So if you deploy the kind of like the Ethereum version, it's quite similar with some changes. Obviously, the instead of DAML execution engine, we ship the Ethereum virtual machine on the replicas, so they will so that they can execute the Solidity smart contracts. And also in the client, we have this EtherRPC server instead of the Ledger API running on the client node. So that's kind of like the difference between the Ethereum version and the DAML version, I will say. Cool. So some customer examples, as I mentioned, with the DAML version. ASX is using the DAML for post-trade clearing and settlement for the Australian equities market. So currently, this is industry testing state, and as of November 2021, and the testing is still under progress. Broadridge is live in production with their repo agreement, repo transactions. So it's processing around 35 billions of dollars of repos, and it's growing. Repos basically, I mean, in a simplistic term, you can think it as a security or government bonds, etc. So um, you can, and let's say you are in need of short-term liquidity, right? So you can sell this the security with a promise to buy back in the future, and the buying back might be maybe overnight, or it can be further down in the time frame, right? So that's kind of like the agreements between buyer, seller, and operator. So that's the repo market that Broadridge operates. And ASX has another use case, Symphony, which is a DLT as a service platform again. It runs VMware blockchain as well as the DAML smart contracts. So basically, Symphony is a platform where customers of ASX can build applications, the apps, and deploy into this platform. Is managed by the Symphony team in this case. So this is again in live in production, and there are customers using this platform now. So I mentioned this briefly. So kind of like how do we deploy the blockchain? If you recall the diagram, I had 6 nodes, right? So 2 client nodes and the 4 replica nodes. So we have an appliance or virtual machine called orchestrator. So what you need to do is you need to create an instance of that orchestrator. It could be on vSphere, as I mentioned, or it can be EC2 instance. And then you need to provide a couple of files, infrastructure descriptor and deployment descriptor. So infrastructure descriptor is basically like the infrastructure options that you want to provide. This can be like what will be the monitoring endpoints, logging endpoints, different availability zones, subnets, network settings, etc., etc. And the deployment descriptor will be the layout or the topology of your blockchain network, right? So for example, I want to run 4 replica nodes plus 2 client nodes, and they will have, let's say, 8 vCPUs, 32 gigabytes of RAM each, etc. Those kind of parameters can be provided in the deployment descriptor. So once you have these files, you can feed those into the orchestrator. Then and you can start the deployment process. What orchestrator does first is generates a configuration, bootstrap configuration. It connects the vCenter or EC2 endpoints to create or bootstrap the virtual machines, and then it creates the virtual machines with the bootstrap configuration. And once the virtual machines are up, they will start the bootstrap process. And as I mentioned, they will do they will do a key exchange, because the generated config will be replaced by the keys generated during the bootstrap process. So they will rotate the keys, and post that, eventually the blockchain network will be functioning. So this usually takes 5 to 10 minutes to deploy a blockchain network. And post that, you can start to deploy your DAML API, DAML applications or Solidity applications. You can deploy into blockchain, the network, and start interacting it. So the deployment is quite straightforward from this point of view. Some other information on the day two operation side. So as I mentioned, the deployment will provide simplified tooling, which can be used for on-prem or cloud deployments. Support is we have the VMware support, as well as the kind of like the SMEs supporting the blockchain itself. Monitoring and logging, we support number of endpoints, which I will touch later. Consumption-wise, it could be deployed into private or public clouds. Capacity management, so we provide functionality around data pruning if it is required, and data archival. So you can archive the data into S3, kind of like object store, and the stale data from blockchain can be removed or pruned in this case. So that's because in some use cases the data generated is quite large, and kind of like some of those data can be pruned if they are there in kind of like archived state. And as upgrades, the tooling, and we provide the tooling and the runbooks to upgrade the blockchain. And obviously it comes with the data continuity that we provide. In terms of observability, so we support multiple monitoring tools, kind of like I mentioned, Wavefront natively. Elk, we can send the matrices to Elk Stack and on CloudWatch as well, if you are using the AWS. So it's basically, it generates hundreds of matrices for replica nodes, client nodes, and even components within them. So kind of like the memory usage, CPU usage, free disk space, etc. Those on top of the kind of like the blockchain matrices generated. In terms of the logs, we support CloudWatch and Elk login site, or we can push the logs to any other HTTP logging endpoints. So kind of like this is the observability features that we have. So I'll do a short demo of both DAML smart contracts and Solidity smart contracts, and kind of like a just to showcase like how they can be deployed and run with the VMware blockchain. So let me go to my so I'm running the instances on AWS. So I created this network here. So it has basically 4 replica nodes as well as 3 client nodes. This is the running the DAML version, and I have one for Ethereum as well. So it's basically 7 EC2 instances in this case. I deployed this before the meeting, so we don't spend much time there. So what I will do with the demo is I will use the IOU sample from DAML. IOU stands for IOU, or in this case, the digital, can think of a digital cache. I have 3 different client nodes. So the issuer, and each of them has allocated with different parties. One for issuer, one for bank A, one for bank B. So what will happen is issuer will issue a kind of like a IOU, and then he will transfer it to bank A, and bank A then will transfer to bank B. This is just to show the kind of like the interaction between the parties. And also, as I mentioned, like there's a privacy filtered subset here, because the issuer, once it issues this IOU, the data will only be available to the client node that issuer access to, and bank A and bank B will not get a physical copy of that information. So I already uploaded these smart contracts and allocated to parties. So what I will do now is I will just start the user interfaces. So I will start 3 different user interfaces. As you can see here, they are basically different browsers for different roles you can think of. They are pointing to different client nodes, as you can see. When I start the kind of like this navigator, each of them is pointing to a different client node IP, as you can see from here. So what I will do now, I will issue one IOU. So I'll just go here, issuer is issuer, owner is issuer, currency is XYZ, amount is 99, let's say. So submit this transaction. So I think, yeah, this one is the one. So I can see that this contract now, issuer, currency XYZ. And if I go to issued IOUs, I can see it here. And if I log in with another, if I log in as bank A in this case, I will not see this contract because I'm not the owner, or I'm not authorized to see this information. So what I can do now is I can transfer this, like let's say to bank A, and it should be available soon. Yeah, as you can see, it's here, and I can accept this transaction. And if I now go to own IOUs, I can see this IOU here, and it shouldn't show up here anymore because as an issuer, I issued this, but I transferred to another party, but I can still see it. It was issued by me. And similarly, if I log in as bank B, I'm not going to see this. And I can go and transfer this to bank B if I want to. And I can accept this. And now I own this IOU of 99. So the bank A doesn't own this anymore. So if I go to my, I mean, for this one, I configured the wavefront dashboards. So just as example, as you can see, as I was doing several transactions, you can see number of writes coming to the blockchain. And near real time, we can see those. And other blockchain related matrices. I mean, it's like number of blocks being generated, like number of fast paths, slow paths. This is basically our consensus kind of like algorithm, how it runs in the fast or slow path, etc. And many other different matrices. I mean, this is a short, small dashboard, but as you can see, like we can generate lots of matrices. And this tool lets you create alerts, etc. So you can action on those the matrices. Similar with the logs, but I'm not going to show the logs, so they are quite similar. This was the demo example, simple. Same with the Ethereum. I mean, I have an Ethereum version of the blockchain deployed. I have a sample application. It's basically what it does is it generates Maybe I can show here. What it does is, so I'm deploying my replica nodes and our Ether RPC nodes, and I will deploy 3 contracts. One is the GST two of them are ERC20 tokens. I named them GST and SCT, but they can represent anything, obviously. And we have like a pool contract which we can use to convert or swap between GST and SCT. And I will deploy them using Hardhat. Hardhat is a tool in the Ethereum ecosystem. It's for developing and debugging and deploying smart contracts. And I will also have 2 personas, Alice and Bob. So they will use something, they will use a user interface to basically transfer tokens between themselves. And for the crypto, for the wallet, it is going to use MetaMask. So basically, MetaMask is configured to point the blockchain installation. So I can deploy the smart contracts. So I'll just call this deployment script. It takes a couple of seconds. What it will do is it will deploy the contract if they were not so, and it will then connect to the blockchain network and start deploying the smart contracts. So it's first it deploy the GST, supply chain, second one, and the swap contracts. And it's basically doing some token transfer between different parties, Alice, Bob, and Charlie, so that we can do the demonstration later. So it's done. So I deployed all my smart contracts. So I can start my user interface, which is already running in the back. So as you can see, this is 53.99. So I have my application here. I have my MetaMask connected to my blockchain network. It's correct. So I can refresh this. So what I have is on the left, I have basically the Alice, and on the right I have the UI for Bob. So the MetaMask is pointing to a different account in this case. So what I can do is I can copy this address. This is Bob's address. I'll paste it here, and let's say I will transfer 10 GSC tokens. So this will ask me some confirmation. So as you can see, this transaction is successful. My Alice's balance dropped to 990, and basically the Bob's kind of like the balance increased to 1010. So we basically transferred 10 tokens to Alice in this case. As I mentioned, it's using this EVM Solidity, so we can use the tools like Truffle, Hardhat, MetaMask, Remix, or Web3.js, etc. So all those tools that you are using can be used here as well. I also provided configured the Wavefront dashboard. So obviously is different. Some matrices will not be available here, but kind of like you can see that the blockchain network is generating lots of matrices and sending to monitoring dashboard as well for observability features. So I think those are the things that I wanted to cover. I don't know if there are any questions, Alikan, that we can take now.
Hey, yes, unfortunately I cannot find any questions in the live chat, but I hope that we will get some more when the recording of this event will be published on our YouTube channel. And just a second, yes. Okay, Erhan, thank you so much for coming to us today, and we will share all the recordings on our YouTube channel, as I said, and feel free to ask any questions, and we will address them to Erhan directly. And yes, one moment. Nikolai Hrustalев. Are there free papers or interactive tools available for estimation of the HW license cost performance features?
Sorry, are there
Yes,
free papers interactive tools available for estimation of the hardware license cost performance features? As of now, I mean, we don't have interactive tools. I guess what the question is, the hardware cost, license cost, performance, like how many, let's say you want to reach X number of transactions on the platform, leveraging this and that features, etc. What will be the hardware license costs? As of now, we don't have a tool to calculate those, but we can always do one-on-one kind of like a consultation if you have a need or a question. Because we have numbers based on experience and based on our performance lab, so they continuously run those transactions and with different settings. So we have those numbers, but it really depends on the use case, etc. So I think we can do it one-on-one consultations when required.
okay, and I think that was the only question. Let's wait a little bit if we will get some more. Yes, and we will also share the presentation. We will publish it on our wearecommunity.io website, and the recording will be there as well, and on YouTube as well. And I think there are no more questions for today. Okay, Erhan, thank you so much once again for coming to us, and that was a very nice and productive session, and it's kind of a workshop format, and we are very pleased to see you as our guest speaker, and hope to see you again.
Thanks, Elka.